Okay, so today we're going to learn how to calculate the pH during a titration of a strong acid being titrated with a strong base. Okay, so we know the volume and the concentration of the acid, and we also know the volume and the concentration of the base. Okay, so what we're going to do is we're going to figure out how many moles of acid there are and how many moles of base. But honestly, what makes these problems easier is the concept of millimoles. So this is molarity is moles per liter, but it could also be written as millimoles per milliliter. And we're going to use that because these are all in terms of milliliter, and it just makes it to be less calculations. Okay, so what we're going to do is figure out how many millimoles of acid there are and how many millimoles of base there are based off these two volumes and concentrations. So let's start with the acid. So we have 25.0 milliliters, and its concentration is 0.175 millimoles per milliliter. Okay, so if we type that in, we're gonna get 25 times 0.175, and we get an answer of 4.375 millimoles. A millimole is just a thousandth of a mole. Okay, and that's how much H plus we have, or H3O plus, whatever. Okay, now for the KOH, which is a strong base, we have 13.46 milliliters times 0.285 millimoles per milliliter, and we'll see what we get there. 13.46 times 0.285, and we get an answer of 3.84 millimoles of base. So the idea is this is a strong acid, so all of this will dissociate into H+, which forms H3O+ in water. And this is a strong base, so it all dissociates to form OH-. These two are going to cancel each other out. So for every mole of H+ and every mole of OH-, they basically cancel each other out and form water. So what we're going to do is take the difference between those two numbers. So we're going to take 4.375 minus our previous answer, and it comes out to 0.5389. I didn't drop any sig figs in my calculator, so maybe I have an extra sig fig here, but it's okay. And then this is millimoles, and the idea is this is the amount that hasn't canceled out, and because we had an excess of H+, this is how many millimoles of H+ we have. Okay, and then to get pH, we need to know the molarity. We know millimoles, but we do not know molarity, capital M. Okay, so what we need to do is figure out the total volume. So we can add these together, and it comes out to 38.46 milliliters total. So to get concentration of H+, or H3O+, what we're going to do is take millimoles divided by milliliters. Okay, so we have millimoles per milliliter, and we'll see what we get. Okay, so I just took this answer divided by 38.46, and I got 0.0140, well, it's probably enough sig figs. Okay, and that's molarity of H+, which in water is H3O+, same idea. So to get pH, we're going to take the negative log of this. Okay, so negative log of our answer, oops. I got 1.85. Okay, if we had done this same problem and we had had an excess of base, the difference between these two numbers would have been the amount of millimoles of OH-. You would still take it divided by the volume, and then when you take the negative log, you would actually get POH and have to subtract from 14. But because we had an excess of acid, we just took the negative log and we were done.